All right, so let's find the area under the curve y is equal to x squared from x is equal to 2 to x is equal to 4. All right, so if f of x is equal to x squared, then it must be the case, from what we did above, that the area function, actually the derivative of the area function, is equal to x squared. Okay, so whatever the area function is, if you take the derivative of that, you get the original function back. Okay? All right, so what we've just set up here is a differential equation. Okay, so if you remember, a differential equation means that we want to find the function that makes this true, right? Because it's saying the derivative of the area function is equal to x squared. So then we want to say, okay, well, what would the function a of x be that would make that true? So what we're going to do here now is just take the antiderivative. So we can say, all right, then it must be the case that the area function is just the antiderivative, so capital F, which is equal to, and then the antiderivative of this would be x to the power of 3, and then multiply by 1 over 3, or over 3, and then plus c. So, sometimes the notation can be a little bit funny, like or a little confusing, what I just went through there with, calling this a differential equation, and, we've got two different f's here. But for the most part, what we did here is we just took the antiderivative of our function to find the area. So in short, that's what it is. I just really want to make sure that you guys see this type of notation too, especially if you're going into university calculus, right? So, all right. So there you go. So from there, though, now that's in general, right? That the antiderivative of this would give you the area, but we don't know what c is. But watch what happens when we actually put numbers in. So the area function, so area, so a of x, is equal to, and it's going to be the antiderivative at 4 minus the antiderivative at 2. Okay, so we're just going to do it twice. We're going to put it into this equation, but just have f of 4 and then of 2 as well. So see what happens here. So we get the area function is equal to, so this would be 4 to the power of 3 over 3 plus c minus, and then the same thing but with 2. So 2 to the power of 3 over 3 plus c. And then notice that my c's cancel, right? Because we're subtracting. So that will always happen when we actually have like a bounded area that we're doing, which is nice. So then if we do that, we end up getting, and we'll just say we're going to have like a different notation actually in the next lesson, but for now, a of 4, and all I'm doing is just taking like the higher value there, just to say the area at 4, right, is equal to, and then, actually I should have said that here too, sorry, a of 4, right? And it's a little bit arbitrary because like it's at 4, but we didn't say anything about the lower bound, but that's just how we're going to do it for now. So a of 4 is equal to, and this becomes 64 over 3 minus 8 over 3 is equal to 56 over 3.